2. So when we are graphing inequalities, you can actually show with symbols all of the different things that the variable can equal. So I like to think of this as a garage door. So when we're graphing, these will make sense in just a minute. So when we're graphing, you always circle the number that it starts with. This is where it starts, and then we're going to show, and I'll show you this in just a second. So when we just have less than or greater than, I like to think of it, right? The garage door is open. Over here, when we have less than or equal to, the garage door, bam, is shut. Boom, the garage door is shut. So on these ones, we just leave our circle open. We circle the number on the graph and we leave it open because it's not including that number. So it's open, it's not included, right? Our garage door's up so you can see straight into the garage. On these ones, boom, it's equal to it. Shut, the garage door shut. You can see it down and closed. So we want to close in the door so you can't see into the garage. Another way I think of it, whenever I say these, I always make a little hand motion. Let me hop over here. So here we can see, right? So it's greater than or less than, it's open. So it's not included. So they're not included. I don't want to fill it in. So whenever I'm thinking of these, so, right, if 4 is equal to 4, it includes it. I always say it includes it, right? I'm gathering all of those. I can have that. So, right, I'm showing that it's closed in. So either way, whether you think of it like a garage door or you include it if it has that equal sign. So every time when I'm doing these, okay, it's equal to, so it includes it, right? This hand motion kind of helps me remember that I want to fill that dot in. So let me come back here. So, right, if it doesn't equal it, it's empty. The garage door is open here, right? It came down, the garage door shut, and we have to fill it in to close that garage door. So let's take a look here at how I would graph these. So let's start here. So we have x is greater than 2. So the very first thing we want to do is make our solution set. So x is greater than 2. So I want you to think of 3 things that x can equal. And again, remember, keep them simple. X is greater than 2. So my first question is always, can it equal 2? 2 is greater than 2? No, that's not true. So it cannot equal 2, but it can equal 3. It can equal 4. It can equal 5. I like to just kind of go in a row. Again, keep it simple. So I'm going to come and find those things. 2, 3, 4, 5. Sorry, not 2, 3, 4, 5. And just make a little mark on those on my number line. So here we're finding 2. And again, so how do I mark 2? So it's open, right? There's no garage door shut. So I'm going to come find 2. And I'm going to circle it with a big open circle. So right now it's saying that x cannot equal 2. But now I'm going to show anything that x can equal. So I drew my solution set as 3, 4, and 5. So I'm just going to connect those and make a forever arrow going on to say, no, x cannot equal 2, but it can equal anything that's bigger than 2. So that's why your solution set is so helpful, is because it's going to show you which way the arrow should go. Okay, let's try another one here. So here's our problem. Our inequality is x is greater than or equal to -1. So the first thing we want to do is make our solution set. So we need to come up with 3 things that x can equal. So it just has to be greater than -1. Or equal to it. So the first question should always be, can it equal -1? Yes, we have this equal sign here. So yes, it can be -1. It could be 0. It could be 3. Those are all greater than -1. So now I want to put these on my graph. So I could be -1. I could be 0. I could be 3. So now I'm going to graph -1, and it's greater than or equal to. So remember that garage door is shut. So I need to put that big circle, and then I need to fill it in to say, yes, it can be -1. It's closed in on that number to trap it in there. So yes, it can be -1. And then I'm going to show it also can be any of these numbers with that arrow to say it's going to go on forever. So this way, right, I don't want to write down every single number X could be, but this shows me anything in this direction would be included as a solution of X. Let's try a couple more. And remember, we're going to practice these for a few days. I know these are new, and I still have to think about every time, should it be closed? Should it be open? But doing the solution set makes a really big difference in knowing which way your arrow should go. So here we want to do X is less than 2. So go ahead and make a solution set of at least 3 numbers that would make this true. So X is less than 2. So our first question, can it be 2? Well, no, because there's no equal sign. So see if you can write down 3 numbers. So some that I chose, I'm saying 1 is less than 2. I'm going to say -1 is less than 2. And I'm going to say -4 is less than 2. So now I want to hurry and just mark these. So 1, -1, -4. And now we are going to mark +2 on the graph. So because it just has this symbol of less than here. So here's our less than. It's open, right? There's no garage door. So it's open. That 2 has escaped out. So here's where we're at. So this is saying it's not equal to 2. But I want to draw my line to connect these. It can be 1, it could be -1, it can be -4, or anything else in that left direction can be a solution to X. Okay, let's try another one here. So we've got X is less than or equal to -1. So this time it's got to be less than -1 or equal to it. So let's come up with our solution set. So the first thing we always want to ask ourselves is, can it equal -1? And yes, it can, because we have this equal sign. So it could be -1. So I want you to see if you can write down 2 more numbers that are smaller than -1 to complete your solution set. Okay, so let's do -4 and -5. And your numbers might be different, but they should just still be to the left here of -1. To get smaller, we go to the left, bigger to the right. So it's not going to matter which numbers you picked as long as they're in the right direction. So I've got -1, I've got -4, and -5 as my choices. So now I come here and I'm going to graph -1. So I'm going to circle -1. And because the garage door is shut, I need to shut in and fill in the garage door. And then I draw my arrow over to say, yes, it can be X, can be anything headed in this direction to the left. So let's try task 2 here. So Y is less than or equal to -3. So the first thing we want to do is make that solution set. So what are 3 things that Y could equal? So remember, our first question is always, can it equal -3? And yes, it can, because it's got this equal sign. So I always like to include that when I can. So I want you to come up with 2 other solutions for Y that are less than -3. So we're here at -3. We want to go less. So think of 2 things that are less than -3. So I'm going to say -5 and -8. So here's -3, -5, 6, 7, 8 would be around over here somewhere. So now I come back to my inequality and I'm going to graph -3. So I circle -3. Now remember, my garage door is closed. So I want to close in my circle. And now I connect all of my solutions. And so anything to the left of -3 can equal y.